So 33 has two parts as well. Part A, we're looking at a ladder which is leaning up against the wall of, let's say, a house here, and it's a 25-foot ladder. All right, and the bottom of the ladder starts to slide away from the wall at a rate of 14 feet per second. So the bottom of the ladder is going out at 14 feet per second. All right. So this ladder is coming down awfully fast, and hopefully there's nobody underneath there. But the question is, how fast is the top of the ladder dropping when this ladder is 7 feet off of the ground? Okay, so we can see that this time we have a triangle involved. All right, and we're interested in the sides of a triangle. So what formula can help deal with sides or missing sides of a triangle? Now, hopefully you're saying the Pythagorean theorem, and that would be the case here. All right, so our formula is going to be a squared plus b squared equals c squared. All right, so we're starting to get an idea as to what we're looking at as far as understanding the problem. And this is a case where drawing the picture hopefully helped out. Okay, so we've got a squared plus b squared plus c squared. We know that c is always our hypotenuse, so there's our c right there. We'll call this 7a. And we don't have a value for b, but we can find the value of b using the Pythagorean theorem. All right, so we'd have 7 squared plus b squared is equal to 25 squared. And if you know your Pythagorean triples, then you've got a value for b. And otherwise, we can square 25 and subtract 49 and then take the square root of that. And it turns out that b is equal to 24 feet. All right, so we now know that b is 24. I'll leave the calculations to you as needed. Okay, and we also don't forget about our 14. All right, the 14 is the rate at which b is changing. All right, it's going out at 14 feet per second in that direction. So we have a dB dt available to us as well. All right, going back to our issue of understanding the problem, what are we trying to find? All right, remember, we're trying to find the rate at which the ladder is dropping. The top of the ladder is dropping. Well, a represents that distance. We're interested in the rate that that distance is changing. That's our dA dt. All right, so we don't know what that is, but we're trying to find it. Okay, so now we have a lot of information to work with, so we can go ahead. We've written our equation. We now have to differentiate it. So let me just get rid of the previous math there. Now we can find our derivative. Okay, so we have a squared. A squared is going to derive to 2a. But again, we're deriving a with respect to time, so we need dA dt. And we're going to then derive b squared, which is going to give us basically the same thing, except it'll be in terms of b instead of a. So 2b dB dt. And then we have c squared. All right, so that's 2c dc dt. All right. Now at this point, we can start plugging in values. All right? We know that a is equal to 7. dA dt is our unknown. All right, so we're going to have 2 times 7 times dA dt plus 2 again, and then b's value is 24. dB dt was given to us to be 14, so 2 times 14 times dB dt, excuse me, let me try that again. 2 times 24 times 14, there we go. Okay, and then for as far as c is concerned, well, the ladder is 25 feet long. Right? And then dc dt represents the rate at which the ladder is changing. What's the rate at which the ladder is changing? Exactly, there is no rate. It's 0. Okay, the ladder's not getting smaller or shorter. It's always 25 feet long. So we're going to multiply this by 0. So this is a case where we're actually going to plug the 25 in right away for here because there is no change to the ladder. Okay. All right, so what we're looking at here is 14 dA dt plus 2 times 24 times 14, all right, and that's equal to 0. Okay. So we can now get dA dt all by itself. We know that 14 dA dt is equal to negative 2 times 24 times 14 if we just subtract that value from both sides. Is that still on the screen? Yes, it is, just barely. Okay, and if we divide by 14, all right, then we see the 14s cancel out. We're left with negative 2 times 24. So we can see that dA dt is negative 48 And we're dealing with feet per second. So this top of the ladder is coming down at 48 feet per second, which is awfully fast.